V. Nagamal. I am presenting about Pythagorean fuzzy set with Topsis and Codas MCDM methods under the guidance of Dr. D. Ajay, Assistant Professor, PG and Research Department of Mathematics, Sacred Heart College, Tripattur. Introduction. I choose Pythagorean fuzzy set with two popular MCDM approaches, Topsis and Codas. My first application is choosing the best laptop among 5 alternatives and 5 criterions. I choose second application, choosing best investment option among 5 alternatives and 5 criterions. Fuzzy Pythagorean fuzzy set. A PFS is an extension of enthusiastic fuzzy set that provides more flexibility in handling ambiguity in decision-making problems. Let I be a universal set. A Pythagorean fuzzy set as follows. P equal to psi comma mu p of x comma nu p of x such that psi belonging to x where mu p of x belonging to 0, 1 is the membership degree of psi. Nu p of x belonging to 0, 1 is the non-membership degree of psi, subject to the condition mu p square of x plus nu p square of x is than or equal to 1. The indeterminacy is given by pi p of x equal to square root of 1 minus mu p square of x minus nu p square of x. Algorithm of PF Topsis application. I selected Topsis to develop a systematic MCDM algorithm for evaluating alternatives. In this study, laptop brands such as HP Pavilion, Lenovo, Dell, Apple, MacBook Air, and ASUS i7 were considered as alternatives. The evaluation was performed based on important criteria including cost, storage, camera, and screen thickness. The Topsis method ranks alternatives by measuring their distance from the positive ideal solution and negative ideal solution. This structured evaluation process ensures an objective, accurate, and reliable selection of most suitable laptop. Alternatives and criteria. Let the set of alternatives be A equal to A1, A2, A3, A4, A5, A1 equal to HP Pavilion, A2 equal to Lenovo V15, A3 equal to Dell, A4 equal to Apple MacBook Air, A5 equal to ASUS i7. The criteria set is considered to be C1, C2, C3, C4. Step 1. Construction of decision matrix. This is my decision matrix. Consider as linguistic terms VH to be very high, high to be H, medium to be M, L, low to be L, very low to be VL. The corresponding weights are W equal to 0.15, 0.35, 0.35, 0.15. Step 2. Normalization of decision matrix, benefit criteria and cost criteria. Substituting decision matrix from one table, we get table 3. This is my decision matrix. Pythagorean weighted matrix. The weight Pythagorean fuzzy is obtained using Vij equal to square root of Wj mu ij comma Wj Vij. From substituting weight values in equation 1, we get weighted fuzzy decision matrix. Step 4. Ideal solution. From equation 2 and 3, substituting decision matrix, we get positive and negative ideal solution. Step 5. Distance measure. Using equation 4, from positive and negative solution, we get these values and final positive and negative solutions with distance measure table. Step 6, closeness coefficient. Using equation 5 we get all the values and this is the closeness coefficient table result. According to PF Topsys MCDM analysis, alternative A4 Apple MacBook Air attains the highest closeness coefficient and is therefore selected as the most suitable laptop among the considered alternatives. Second application is selection of best investment using CODA's MCDM method. CODA stands for Combinative Distance Based Assessment. Application. I choose 5 alternatives such as fixed deposit, mutual funds, real estate, gold, silver, and cryptocurrency. I choose 5 criteria: liquidity, returns, and risk level, investment horizon, and fees charges. Step 1, construction of decision matrix. Let the alternatives be A1, A2, A3, A4, A5. Let the criterion set is C1, C2, C3, C4, C5. This is my first decision matrix, second decision matrix, third decision matrix. Using linguistic scale table 4, substituting decision matrix 1 and 2 and 3, we get table 5, 6, 7. From alternative A and criterion 1, substituting in equation 6, we get table 8. Step 2, normalize decision matrix. In equation 7 and 8, substituting table 9, we get PF CODA's normalized decision matrix. Step 3, weighted normalized Pythagorean fuzzy matrix. Weight W equal to 0.2, 0.25, 0.25, 2, 1.1. Equation 9, we get these values weighted normalized decision matrix. Step 4, negative ideal solution. Above equation substituting weighted normalized values, we get negative ideal solution. Step 5, Euclidean distance calculations. Above equation 5, substituting values, we get final Euclidean distance values. Statistic gap distance calculations. From equation 11, we get all the values. This is final taxi cab distance table. Step 6, compute relative assessment matrix. From equation 12, substituting all the values, we get relative assessment matrix. From equation 13, substituting all the assessment matrix values, we get assessment score matrix. Result. In relation to the negative ideal solution, the relative assessment matrix and Euclidean gap distance measurements was calculated using Pythagorean fuzzy CODA's MCDM methodology. Alternative A4 received the highest relative assessment value out of all the options based on the evaluation result. Conclusion. By using the Topsys and CODAS approaches to solve real-world decision-making issues under uncertainty, this project demonstrates the efficiency of Pythagorean fuzzy MCDM methodologies. Pythagorean fuzzy set increase evaluation accuracy and effectively capture subjective expert judgments based on the maximum proximity coefficient. The PF Topsys approach designed the alternative A4 MacBook Air was the best choice in the laptop selection. In a similar way, A4 Gold Silver was ranked as the best investment horizon using PF CODA's approach. Overall, the findings show that the suggested approaches are dependable, consistent, and useful for application involving complicated decision matrix.